cancerous tumour hides itself, secretly growing in our body, secretly taking over. Like this model who disappears into the background, it deceives the immune system by making itself unrecognizable to our defense cells. And fighting something invisible is a hopeless task. In order for our body's defense system to do its job, it has to know the tumour is there. At the VUMC, we are in the process of creating the perfect uncovering trick, a cancer vaccine.
To understand this uncovering trick a bit better, we need to take a closer look at the surface of a tumour. What we'll find there are glycans. These amazing entities play a central role throughout the human body. Every cell in our body is covered with a complex network of glycan structures that forms the outer space of our cells.
Glycans are composed of small building blocks that are similar to the sugar we use in our coffee. Several of the glycans' chemical and physical properties are passed on to the cells they are attached to. Cells in turn use glycans to communicate with each other, as they can be recognized by the immune cell's receptors. When these receptors encounter unwanted cells, they normally trigger the defense system. However, a tumor cell is also disguised by a shield of glycans, telling the body's immune system it's a good cell that should be allowed to grow. If we could learn this glycan language, it would enable us to speak directly to our defenses, saying, "This is a tumor, attack." Giving instructions like this will be the cancer vaccine's task.
The technique is similar to well-known vaccines, using pathogens to trick the body into making antibodies, like the flu vaccine. Before injecting a part of the tumour cell into the body, a glycan is attached. This helps it bind to the dense network of dendritic cells in the skin, just like pathogens do. Dendritic cells process antigen material and present it to the immune system. The glycan tells the dendritic cell, "Capture me and take me to the lymph node."
The lymph node is the place where our defense system is really activated. T cells can be found there, waiting for a match with the dendritic cell, waiting to be activated. If the vaccine meets the T cell specifications, it will start to multiply into millions of identical T cells, creating an army that will march throughout the body looking for a tumor to destroy. But this army can only attack a tumor effectively if at the same time we dismantle the glycan shield.
The glycan language is difficult to unravel. To take up this challenge, we have developed a battery of highly sophisticated reagents that we can use to monitor single-cell glycans and immune activation. This process is made possible by using a state-of-the-art technology called CyTOF. With this technique, we are now able to uncover the language that tumors speak. We also use CyTOF to monitor a patient's responses to our vaccines, allowing us to fine-tune and optimize them in pursuit of our goal: a personalized, high-precision vaccine.
Our own bodies are capable of curing cancer. All we need to do is help it a little by learning to understand the glycan language. That's what this vaccine is for.